Hello all, welcome to my YouTube channel. Today we shall do hypothesis testing for two means when population variances are unequal. Okay, so for two samples, brand A and brand B of fertilizer, sample sizes, sample mean and sample standard deviations are given, and we can see that sample sizes are very small, 14 and 6. So we can do t-test for small sample if population follows normal distribution. So it is mentioned that yields are assumed to follow normal distribution. Okay, and we have to test whether mean yield of brand A is less than that of mean yield of brand B. Okay, we shall start our t-test for two means with unequal variances. See, for unequal variance and for equal variance, the formula for t statistic is little bit different, and also calculation of DF is little different. Okay, for equal variance, I have also uploaded a video. You can go and see my video t-test for two means. Okay, and we shall start our hypothesis testing step by step. We shall do both methods, conventional and p-value method. In conventional method, what we do, we find out the critical value and we compare the critical value with the test statistic. Okay, and in p-value approach, what we do, on the basis of the test statistic, we find out the p-value and compare the p-value with the level of significance. So let us start. Step 1 is the formulation of null and alternative hypothesis. This is a test for two means, and first we write down the null hypothesis, which is the hypothesis of no difference. In the null hypothesis, we say that mu1 is not different from mu2, where mu1 is the mean yield for brand A and mu2 is the mean yield for brand B. An alternative hypothesis will be based on the question. What is the question? Mean yield of brand A is less than that of brand B. So mu1 mean yield of brand A, which is less than that of mean yield of brand B. Okay, we can see that the alternative hypothesis is containing this less than sign. Okay, so this is called left directional alternative hypothesis, and the test is called left tailed test. Now we shall go to the step 2, that is calculation test statistic, which is given by t equal to x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2, where x1 bar and x2 bar are the sample means, s1 and s2 are the sample standard deviation, n1 n2 are sample sizes. Okay, so putting these values, we 7 minus 10.14 divided by under root of 1.22 square divided by sample size, that is 14, and another sample standard deviation is 4.59 square divided by sample size 6. So we get the value of test statistic to be negative 1.65. We can keep up to 2 decimal places. This is generally the test statistic values are put. Okay, now we shall all step 4 is the decision. Okay, what was our value of test statistic? We have calculated it to be negative 1.65, and the critical value of t at 5% level of significance with degrees of freedom 5 is negative 2.015. We can see that the calculated value of t is greater than negative 2.015. Okay, thus we fail to reject the null hypothesis, because our critical region was in the left side of negative 2.014, that is, if t less than negative 2.015, then we reject. Since it is not less than, that is why we fail to reject the null hypothesis. The final step is conclusion. Since we have failed to reject the null hypothesis that mu1 equal to mu2, then we cannot accept the alternative hypothesis, that is mu1 less than mu2. Okay, thus we conclude that there is not sufficient evidence to conclude that mean yield of brand A is less than that of mean yield of brand B. Now we shall go to p-value approach. In p-value approach, the step 1 and step 2 are same, that is we formulate the null and alternative hypothesis and we can say that this is a left tail test, and then we calculate the test statistic and also the degrees of freedom. The third step is the calculation of p-value. Okay. Since this is a left tail test, p-value will be at the left tail of the t distribution. Okay. Our calculated value of test statistic is negative 1.65, okay, and the p-value will be in the left side of negative 1.65, okay. So, the formula for p-value is probability that the t less than negative 1.65, okay. For t test, this p-value calculation is not possible manually or using the t table curve, okay, critical value of t table. We shall use any of the software. So, I will use Excel formula to calculate the p-value. In Excel, in any of the cell you put equal, then t dot distribution, okay. Since this is a left tail test, so we are keeping only t dot distribution, not two tail, not right tail, okay. Then we put x, that is the value of the test statistic, that is negative 1.65, then comma degrees of freedom, and since this is a left tail area, okay, so we need the cumulative distribution, okay. So, for cumulative we write down true. So, this is the p-value 0.0799. So, now we put the value 0.0799. So, this area is 0.0799, okay. Now, in p-value method, how we come to conclusion, that we will do in the step 4. We compare the p-value with the level of significance, okay. We compare the p-value with the level of significance. Here p-value is 0.0799 and level of significance is 0.05. So, we can clearly see that p-value is greater than the level of significance. Then our decision will be fail to reject the null hypothesis. Remember, for p-value method, whether it is a left tail test or a right tail test or a two tail test, if p-value is less than the significance level, then we reject the null hypothesis for all type of tail test, okay. So, since in our case our p-value is greater than alpha, therefore, we have failed to reject the null hypothesis. Step 5 is the final step, which is same as for both the method, p-value and conventional method. Since we have failed to reject the null hypothesis, we cannot conclude that mean yield of brand A is less than that of mean yield of brand B. Okay. Hope you liked my video, and if it is useful to you, please like and subscribe my channel for more such videos. Thank you for watching.